With the web comes an asynchronous programming model that can be difficult for new developers. This is the first of a three-part series where I'm going to cover different ways of managing asynchronous data with JavaScript. Hi, my name is Stephen Fluin, and today on Demos with Angular, we're digging deep into the idea of callbacks, which was one of the first ways that we dealt with asynchronous programming in JavaScript and on the web. There's lots of really great APIs out there that use callbacks, and they're a core part of the web still today. All right, so in order to take a look at callbacks, we're just going to start with a blank editor here. So this is just a JavaScript or TypeScript editor here, so I can say let x equals 4, and that's going to work. We can define functions like do thing 1, and then I can define another function do thing 2, and everything here is going to work. And now, when you think about a normal JavaScript application, when I say do thing 1 here, and then I say do thing 2 here, everything's going to execute exactly in the order I put it. So all of the code up here, it's going to start by assigning this variable, then it's going to do thing 1, it's going to do thing 2. All of this happens synchronously. So the process actually waits for thing 1 to finish before it goes on and executes thing 2. But because there's a lot of things in JavaScript that happen asynchronously, whether we're waiting for the user, whether we're waiting for an event coming from the web, whatever asynchronous event needs to happen, sometimes we can't actually do thing 2 until thing 1 is completed. And so the most common way of doing this is a callback. And so, for example, if we wanted to make do thing 2 happen only after thing 1 was complete, we could say this takes a callback, and then do thing 1, and then call the callback. And now, instead of calling this function directly after it, I could actually just pass it in. And so what's going to happen is do thing 1 is going to execute, and then only when it's complete is do thing 2 actually going to happen. And now this happens a lot in JavaScript. So a couple places you'll see this is if you ever set timeout, or if you set interval, so you can do thing 2 here, and then you'll want to give it a timer. So how this will execute is this JavaScript will all execute immediately, and it will create a timer in the browser that waits for about 1 second. And then when that 1 second is complete, it will run the code that you gave here. Now, there's a couple other ways that callbacks end up getting used. Often callbacks will end up being called success or failure. So we'll just maybe create a success function, and we'll create a failure function. And often these will take parameters. And then what ends up happening is when you call these, you'll actually pass in a success callback for if the function was successful, or you'll call in a failure callback for if the function was a failure. One of the examples of this is if you look at the navigator/geolocation API, and we want to get current position, for example. So this is going to take a success callback, and this is going to take a failure callback. And then optionally it can take some options, but I will just leave that out for now. So what's going to happen is you're creating a background process in the browser that's going to be asking the user for permission to get their location, and then it's going to be trying to do a GPS lock for the user. And if it's successful, it's going to call all the function here with the actual position that you got back. And if you got a failure, then it's going to call the failure callback here. And it's going to call it with the data that is appropriate for that specific callback. So you're going to see this all over the place in browsers. And one of the things you're going to end up seeing a lot if you do a lot of JavaScript development is a lot of times this will be defined inline. So instead of actually calling out to a named function, this will be an anonymous function. So we'll say like success data, do something with the success data, and then we'll say failure data, and then we'll do something with the failure data. And it's important to realize that when you're defining a callback like this, when you're defining a, or even calling a method that takes a callback, you're not running either of the callbacks until this action completes. And so, but this is how we take a single threaded language like JavaScript, and we add in a little bit of event-based asynchronicity, right? Our program restarts its execution, or resumes our execution at this function as soon as this asynchronous event has completed. And you can create a bunch of these, and the browser will automatically manage them and execute them in the right order. So if I say set timeout, and I say, maybe we just console.log hi, this will work just fine. And what will happen is it will define one asynchronous event up here, So as soon as geolocation comes back, it's going to call one of these functions, and then it's going to create another asynchronous event that says as soon as the timeout finishes, it's going to call console.log hi. So these functions could execute in any order, but I've defined them synchronously, and then they'll execute asynchronously. One of the problems that exists with callbacks is that you end up having to create these kind of success failure cases in a lot of different places, and oftentimes you're defining what you do with the data very, very close to the place where you execute the asynchronous function. And we'll see in a later episode that this isn't always best, and that there's actually better ways of doing these sorts of things. The other problem that we see with callbacks is that if I wanted to make another asynchronous event in here, I can actually end up being kind of very deeply nested. So if I wanted to set timeout here, and I wanted to do something else, and then in that set timeout, I wanted to do another set timeout, or maybe make another web request, or do something else, this actually becomes very hard to understand and very hard to process, right? So I think I need another comma here, and you can just see the programming gets very complex because you're not sure what's executing when, and it's very hard to follow logically. And so some of the strategies we're going to take a look at in future episodes actually allow us to pull some of these things out and define them at the same level, and so that you have a simpler mental model for handling this asynchronous data. Now you've learned some of the basics about asynchronous programming using callbacks. Check out the next video on promises.